Hello, this is Mrs. Ward, and I'm going to go over the 9-6 classwork. So we're going to start with number 3. This one is a shortened version, so pay attention to the numbers that we're doing because they're slightly different than what might be on your note sheets. Open, updated those. All right, so the first one, it says in exercises 1 through 4, a point and a polar coordinate is given. Find the corresponding rectangular coordinates for that point. So I have my r is equal to -1. My theta is equal to 5 pi over 4. I want to change that to rectangular. So I'm going to follow this formula here that says polar to rectangular. And I'm going to say to find x. X is equal to my radius, which is -1, times the cosine of 5 pi over 4. These values are on my unit circle, so I'm not going to use a calculator to find them. I'm going to take -1. The cosine of 5 pi over 4 is a negative square root of 2 over 2. And when I multiply those, my x value will end up being a positive square root of 2 over 2. To find the y value, I'm following the same pattern, but now I'm using this one for y. Y is going to equal r, which is -1, times the sine of 5 pi over 4. So y is equal to -1, and then the sine of 5 pi over 4 is a negative square root of 2 over 2. And so I'm going to get a positive square root of 2 over 2. So my ordered pair, which is in a normal parenthesis, is a square root of 2 over 2, square root of 2 over 2. And that's all I have to do. Oh, that's all I have to do for that. Next one, in exercises 5 through 12, plot the point given in polar coordinates and find the 3 additional polar representations of the point in the interval from -2 pi to 2 pi. So the first thing I'm going to do is I'm going to change this to rectangular. So we're going to follow those formulas, and I'm going to go grab those for you. Okay, so I have the formulas here. So now what I'm doing is I'm changing. I'm just going to do that. Why did I do that? So now I'm going to change the polar to rectangular. No, I'm not doing that. I'm sorry. I'm plotting that point. 0, -pi over 4. I don't like that one because my radius is 0, which means it's going to be right here. It doesn't matter what the angle is, it's going to be 0. So now I'm going to come up with another one. Let's say I do 14. Oh, well, I guess I should do the 3 additional. So if I have 0 here, I could do 0 pi over 4, 0 3 pi over 4. I could really do 0 in any angle. So that one's kind of not a very smart problem. The next one, 2 7 pi over 6. So I'm going to graph that. So if I'm looking at my graph paper, this would be radius 1 here. This would be radius 2. So I'm going to be somewhere on that circle. And then at 7 pi over 6. So you remember that this is 1, 2, 3, 4. So it looks like these are each of 6. Like these ones, this looks like it's pi over 6. So this would be pi. 7 pi over 6 would be here. So here's the angle 7 pi over 6. So what's going to happen is I have this angle 7 pi over 6, which goes on this line here. And then I have the circle, radius 2, which I'm going to say is here. So I want the place where those two intersect. And that's going to be right here. So that's my dot. That's 7 pi over 6. So that's one way I can represent that point, is 2 7 pi over 6. That's me starting here at the positive x-axis and going in a positive direction to 7 pi over 6. But what I could have done is I could have started at this positive x-axis. Instead of going counterclockwise, I could have gone clockwise, which means I'm going to subtract 2 pi from that. So I'm going to take 2 pi, and I'm going to subtract 7 pi over 6. And so that would be 12 pi over 6 minus 7 pi over 6. And that's going to give me 5 pi over 6. But I'm going to make that negative. So this will be 2 negative 5 pi over 6. So that's me starting here and going down here. Both of them are using that yellow highlighted angle. But remember, with polar coordinates, I can look at the angle opposite. So the angle that's opposite is this angle right here, which I wrote as, which I know was 7 pi over 6. If I wasn't sure what it was, I could just take that 7 pi over 6 and subtract 1 pi. So 7 pi over 6 minus 6 pi over 6. And I would just get pi over 6. So my angle would be pi over 6. But since I want to go pi over 6, but I want to hop the pole and I want to go to the other side, I'm going to make my radius a -2. That would be me going up pi over 6. Or I could start at my positive x-axis and go the other direction. So I could start here and go all the way around here. So to do that, I would subtract 2 pi. So I would take pi over 6 minus 2 pi. So that would be pi over 6, common denominator, 12 pi over 6. And get a -11 pi over 6. So I could have -2, 11 pi over 6. So the 3 ways to represent this exact point that they give me is the one that they gave me, 2, 7 pi over 6, 2, -5 pi over 6. Those are following the yellow angle. And then -2 pi over 6 and -2, -11 pi over 6. Got my negative sign. So those are the ways that I can represent that one point 3 different ways using polar coordinates. Okay, the next one, plot the point given in the polar coordinates and find 2 sets of polar coordinates that represent. So I have 1, 1, and I want to change that to a polar coordinate. So I'm following this pattern right here. And I have my x and my y. So let's find the radius first. So I'm going to say r squared is equal to x squared plus y squared. So r squared is equal to 1 plus 1, so r squared is equal to 2, so r is equal to the square root of 2. And then to find my angle, I'm going to say the tangent of theta is equal to my y, which is 1, over my x, which is 1. So if I didn't know this, which you kind of should notice, I'm going to do the inverse tangent of 1. 1 over 1 is 1. That's going to be theta. And when I put that in the calculator, remember my calculator, since I'm doing the inverse tangent, if I go back to this, it's only going to give me an answer from the first and the fourth quadrant. So when I do this, it ends up giving me 45 degrees, or I can think of that as pi over 4. Those are the same angle that I got from my calculator, or I know my unit circle. I checked that this here, 45 degrees of pi over 4 is in the first quadrant. This point is also in the first quadrant, so I'm good to go. I'm going to leave it like this. So I am going to write my polar coordinate, so my radius is the square root of 2. My angle is pi over 4. Going back up here, making sure it wants me to find 2 sets of polar coordinates. So I have one set, and I have to be between 0 and 2 pi. So when I do 0 to 2 pi, I'm only going this way on my circle. I can't go counterclockwise because I cannot have a negative angle. So this 2 pi over 4, and then the other one, so pi over 4 is here. To find the other one, I'm going to have to go to the angle that's opposite of that. So I'm going to take pi over 4 and add pi because I'm going halfway around the unit circle. So pi over 4, common denominator, 4 pi over 4, and I get 5 pi over 4. So my angle is going to be 5 pi over 4. And then since I'm on the opposite side and I need to hop the pole, I'm going to make my radius negative. So those are the 2 pairs that represent 1, 1. Okay, let's do number 36. It's 512. So the first thing I'm going to do is say r squared is equal to x squared plus y squared. So r squared is equal to 5 squared plus 12 squared. So r squared is equal to 25 plus 144. R squared is equal to 169, square root, and r is equal to 13. To find my angle, I'm going to have to have the calculator for that one because that's not on my unit circle. Okay, so I have my calculator all ready to go. So I am going to find my angle, I'm going to skip to the inverse tangent of my y, which is 12, over my x, which is 5. 12 and 5 are not on my unit circle, so I'm going to have to use my calculator. I'm typing in the inverse tangent of 12 out of 5. It gives me that because my calculator is in radians. I'm going to go ahead and change that to degrees. So, I'm not where I need to be. So I like to use the DD. If you don't have to use DD, you can do times 180 times pi over 180, and 180 over pi, 180 over pi. So I have 67.4 degrees. Let's just go with one decimal. So this would be so that's my angle. So before I go write that, I'm going to check if this point is in the first quadrant. This angle is also in the first quadrant. So since they match, I'm good to go. If they did not match, I would either make my radius negative. I would definitely make my radius negative. I would make my radius negative, or I could add 180 to my angle. So this is my first one, 13, and then 67.4 degrees. That's my first one. Now to find the second one, remember, 67 is up here somewhere. I want to half the circle and go down here. To do that, I'm actually half a circle away. So I'm going to add 180 to that angle. So I'm going to take that 67.4, add 180, and the new angle is 247.4. So 247.4 degrees, and then that makes my radius 13. Remember, you have to follow the directions that were given. So both those angles have to be between 0 and 2 pi, or between 0 and 360 degrees if you decide to change it to degrees, which I think degrees makes more sense, but hey, it's just me. All right, convert. So those are changing the points from one to the other. Now we're going to do equations. So right now I'm given a rectangular equation, and I want to change it to a polar equation. So going from rectangular to polar, easy peasy. All you have to do is you double up here, and I'm just going to rewrite x. Every time I see an x, I'm going to write r cosine. Every time I see y, I'm going to write r sine. So r sine theta is equal to r cosine theta. And then divide both sides by r. No, yeah. Okay, so I'm going to divide both sides by r. And when I do that, I get sine theta is equal to cosine theta. But if I divide both sides by cosine theta, I'm going to get sine of theta over cosine of theta is equal to 1. Well, sine of theta over cosine of theta is tangent of theta. And we say the tangent of theta is equal to 1. So that could be one of my equations. Or an easier way to do this, if I would have realized, if I would have thought to look at here and say the tangent of theta is equal to y over x, I could have just divided both sides here by x, and I would have had y over x is equal to 1, so then I would say the tangent of theta is equal to 1. That would have been quicker, but I didn't think of it, so I didn't do it. All right, next one. I have 4x plus 7y minus 2 is equal to 0. So I'm going to change 4 in place of the x. I'm going to write r cosine theta. In place of the 7, I'm going to write r sine theta. And minus 2 is equal to 0. So now I'm going to have 4r cosine theta plus 7r sine theta is equal, I'm going to put the 2 onto the other side. I'm going to factor out an r and make this 4 cosine theta plus 7 sine theta is equal to 2. Now I'm going to solve for r, so I'm going to divide both sides by this 4 cosine theta plus 7 sine theta. Same thing goes over here. So r is equal to 2 over 4 cosine theta plus 7 sine theta. And I'm trying to think if there's anything I want to do to that, and I don't think I do. I have r on one side by itself, everything else on the other side. I got rid of the x and the y and replaced it with r and theta, and that's what you're doing when you're changing polar to rectangular. Okay, this one, I'm changing rectangular to polar. So now I'm going the opposite direction. If I see this x squared plus y squared, I'm going to replace that with r squared. We're going to have r squared squared is equal to, I can't do that, so 9 and r squared cosine squared theta minus r squared sine squared theta. So this would be r to the fourth is equal to, here I can factor on r squared and make this 9 r squared cosine squared theta minus sine squared theta. I feel like I could. Let's divide both sides by r squared while I'm here. So we have r squared. Then I think I'm going to replace cosine with 1 minus sine or sine with 1 minus cosine. Let's do the sine. No rotten reason why. So if you remember way back when sine squared theta plus cosine squared theta is equal to 1. So I can say that sine squared theta is equal to 1 minus cosine squared theta. We did that in trig. So in place of this sine, I'm going to write 1 minus cosine. So that 9's still there. So I'm going to have cosine squared theta minus 1 minus cosine squared theta. So then when I distribute that negative sign, I'm going to have cosine squared theta minus 1 plus cosine squared theta. So we have r squared is equal to 9 times 2 cosine squared theta minus 1. So if you get this far, I'm happy, but you're going to, if you check the back of your book, you're going to have r squared is equal to 9 cosine 2 theta, because I'm sure none of you remember, but this is a double angle identity. But if you get this far, that's fine. If you would have replaced the cosine with 1 minus sine squared, you're still going to get something similar. Try and condense it down to one trig function if you can. Okay, the next one, I have y squared is equal to x cubed. So I'm going to go back and use this guy here for a second. So in order to do that, I would divide by x squared, and I know I'm going to have an x there. I'm okay with that. So this y squared over x squared would be tangent squared theta. And then when I divide this, I'm going to be left with x. So I'm going to take tangent squared theta, and this is equal to r cosine theta. That's what x is equal to. If I divide both sides by cosine theta, so I have r on one side by itself, I could rewrite this as tangent squared theta, and the reciprocal of secant of cosine is the secant, so secant theta is equal to r. And that would be my final answer. Again, you have to remember a lot from the trig identities. Okay, the next one, I have theta is equal to 11 pi over 6, so I want to change this polar to rectangular. So I'm going to use that fact that if I take the tangent, since I'm given an angle, that if I take the tangent of theta, if I take the tangent of this side, I'd have to take the tangent of this side. So tangent, remember, is y over x, and then the tangent of 11 pi over 6, well, that's down here on my unit circle. The ordered pair is square root of 3 over 2, negative 1 half. Tangent would be negative 1 half over the square root of 3 over 2. So negative 1 over the square root of 3. So negative 3, no, I did that wrong. Negative square root of 3 over 3. So negative square root of 3 over 3. So y is equal to a negative square root of 3 over 3x. There I've changed all my theta and my r's and thetas to x's and y's, so I'm good. This one, I have an r on one side and a cosine on the other side. Okay, we're taking off 76 and I'm replacing it with 72. So this one, I have r is equal to 2 secant theta, So I'm going to think of this as r is equal to 2 over the reciprocal of secant is cosine theta. And then I'm going to multiply both sides by the cosine of theta. Now on this side I have r cosine theta is equal to 2. R cosine of theta is x, so this will be x is equal to 2. This one we skip because this is a double angle, and I know you guys don't need this. For the next one, I have 1, r is equal to 1 minus cosine theta. I'm going to get rid of the denominator, so I'm going to multiply both sides by 1 minus cosine theta. I'm going to multiply this r by 1 minus cosine theta. Remember, when I multiply this r, I'm distributing it, so I'm going to have r minus r cosine theta is equal to 1. This, as soon as I can do it, I'm going to do it. That's going to be x. I'm going to have r minus x is equal to 1. So I'm going to add x to both sides, so r is equal to x plus 1. In order to get rid of that r and replace it with x or y, you'll notice that the r has to be squared. There's only 2 ways that I can make the r squared. Is I can square both sides, or I can multiply both sides by r. In this case, since I have r1 by itself, one side by itself, and I don't have a trig function on the other side, it's going to be easier for me to square both sides. So I'm going to have r squared is equal to x plus 1 squared. Now this r squared is going to be x squared plus y squared. And when I square this, I'm going to have x squared, FOILing, plus 2x plus 1. Now I'm going to subtract x squared from both sides. And I have y squared is equal to 2x plus 1. So that you should recognize as a parabola, because it's just one variable squared. And we should put it in the standard form of a parabola. So now y squared is equal to, I have to factor out this number, so I'm factoring out a 2. So this will be x, and then I'm going to have plus 1/2. So you don't have to graph it, but if you did have to graph it, you would know that your vertex is at negative 1/2, 0. This is how you find your focus. You would set 4p equal to 2 to find your focus. Okay, the last one, I have theta on one side, I have an angle on the other side, so remember I'm trying to get rid of the theta and replace it, so I'm going to use this. So I'm going to take the tangent of the left side is equal to the tangent of the right side. So this tangent, I'm going to leave this, well, I'll just write tangent right now. Tangent theta is equal to the tangent of pi over 4 is 1. I know that from my unit circle. So I have y over x is equal to 1, multiply both sides by x, and I have y is equal to x. And I believe that's the last one. That is. I hope this helps, and we will see you next time in class.